Okay, so we are in geometry, and in the geometry I have to get everything together now. The question says find all of those angles, and there's the sketch. Now, it can be less difficult, it can be more difficult, but all the time I'm teaching you a technique in geometry. So in this specific question, there's a few things that I've got to go and establish. Why are all these little lines over here? What does it mean?
The equal.
Okay, and what does that mean? Which theorem might be there?
Bow tie.
The bow tie might be there because it's the one that's separated from each other. Meaning that, and I didn't write down the angle that I actually have, was 125 over here. Okay, this angle A3 was 125 that I have, that I must go work with to get to other angles as well. Now this was a tangent. You've got to read it from your sum. They gave you that it was a tangent. So what I always do is I highlight it for myself so that I cannot forget it. Because usually,
It's 25.
is it just 25? Thank you very much. I was going to say, sums are not according to scale, but obtuse must really be obtuse. Okay, thank you very much. So if this is 25 and I see a tangent, the first thing that must come to mind is tangle theorem, which is the 9th one. So we're working backwards. No, not really. But it's a good idea to always go check out the tan-chord theorem. So if that is the tan-chord theorem, what will also be 25?
C1.
Excellent. And that was my first question. 2 marks for saying that C1 is equal to A3, which is equal to 25 because of the tan-chord theorem. No reason, no marks. No reason, no marks.
Equals to A1.
Oh, thank you. But there's a 1.
Yes.
And there's a 3 then. Alright. Answer done. Highlighted, I've done it. Second question asks for C2. How will I find C2 then? Now you told me at the beginning which one am I looking for? The moment I see all of these little thingies equal to each other, it's the bow tie that's been separated from each other. Not very separated, but these are the 2 things that are equal. My sketch looks much smaller and much bigger, but I'm telling you, looks can be deceiving. You go according to what's given on the sketch. If I say it's equal, then it's equal. Although you can see it's longer. So if this is equal to that, where's the bow tie? So C1 and C2 will be equal to each other. How come? The bow tie, right? Angles? Angles in equal circle segments. Not the same circle segment, it's equal because they're on separate chords. Next one asks for C4. Now it's getting more difficult, and in an exam you'll see this was given 2 marks, this was given 2 marks, the next one might be 4 marks. So you think, okay, well, I've got to go do some more stuff here for 4 marks. So I'm getting the idea that maybe for C4, maybe it'll be on top of this one. Do you agree? Or is it? Is it in the same circle segment? But let's see what I have. Don't I also have cyclic quads? You see it? Do you see a cyclic quad?
Yes.
And another cyclic quad for that matter. Do you see it? Are these opposite angles of a cyclic quad? No, there's not the same cyclic quad, so you can't do that. Are you with me? Don't start thinking all sorts of other stuff. Let's start from the beginning, because out of my fist I could just go do these 2. But if this is the center of the circle, what else is there I can use? Diameter. So then this would be 90. Is it going to help me? Please go put everything that you've got already on your sketch, otherwise you're going to lose some stuff. So they were both 25 for good reasons. But if this is 90, then how much is D? Interior angles of a triangle. Just make sure that you add it up with your calculator, that it does add up to 180. Please remember that these 2 add up to 90. Right. Then I can go and say, okay, let's go through all of our stuff. Theorem 1, line from the center of the circle. Well, it's not going to the center of the circle, so it's not there. Angle at the center twice there or the circumference, or even the skew ones or the bolted in ones. Okay, is it? No. Okay. Then the semicircle was there because they said it was a diameter. That's how I got to the 90 there. What else? Bow tie? Well, bow tie is there. I'm thinking twice. This was equal, then I can go over there. This is going to be another one. Look at it. To that side. But does that mean these are going to be equal? Because remember, it's going to be angles in the same or equal circle segments. If this is the two-lined one, going to this side, the smaller side, do you think that one is going to be the same there as well? Just keep it on ice for a minute. Okay, or is it going to be to that side? Let's see. Cyclic quad, well there's two of them, but I've got nothing there. But over here I do. So if I can get across to those two lines, this one would be how much? Not 65? Because opposite angles are supplementary. Please, they're not equal. Cyclic quad. Exterior angle of a cyclic quad. Why not? Because it's not one of the lines extended. Not one of the lines of the cyclic quad extended. So this is not exterior angles. Another tangent tan chord theorem, maybe. Isn't there another one, maybe? Can I not say this one is also equal to that one? Well, you can. So this will mean that this is also 25. Do you see it?
Yes.
Tan chord, take your fingers to the chord, go to that side. Just like over here, tan chord, take your fingers to the chord. That means that they're equal, both with tan chord. Okay. But you needed this 90 as well to get here and to get to the... But ma'am, I'm not getting to where I want it to be. I don't have C4 yet. How will I get to C4? Ideas? Angles in the same circles are equal circle segments for which one?
For D and C4.
C4 and D. Okay, I hear what you're saying. So it goes to this side and goes to that side. Do you want to say 65? Is that fine? Because it's on the same chord. This one going to 65, this one going to 65. Do you see it? What he saw? So what was this all about? Oh, I think mumbo jumbo. Sometimes we can get stuff that's not necessary, but we might still want to work with it. So if this is 65, and I still need to get to G. Oh, G. Okay, what? All my jokes are good. Especially that one. 65 there, how much will this then be? How come? Now this was actually what I wanted to do, because guys, if I had this 115, could I not have said that that was 115? So that's the other way around, and it doesn't matter as long as I can follow your train of thought. That's very important. Okay, so where did I go with this? Did I actually use the 65? Yes, well he did. Okay, and I did use it for the sum of the angles of a triangle, and then I got the 115. Then I wanted to get that one, but he got this one first, and then he used. Are you with me? We're not all going to write it exactly the same, and we can go this route and that route and still get to the same answer. Sit still. So then for the third one, what did I first work out?
So that A3.
A3 was 90. That's important that I first got to say why that is so. For the angle in a semicircle, before I could get to D, that was 65. How come? Interior angles of triangle. Am I right? Yeah, see? Right, and then I got to B. What was I actually looking for, by the way? Sorry. C2. Sorry, C4. I'm the one. No. Yeah, sorry. C4 would be the same as, that's if we're following his lead. C4 would be the same as angle D because angles in equal circle sequence. So I've done C4. Now I've got to go get to G. So now he's working the other way around as what I was working, but still we're going to say for the fourth one, G would then be not the same as C4, but it would be 115 again because of opposite angles of a cyclic quad. And in this case, it would be a good idea to say cyclic quad G, F, C, E, in whichever order, doesn't matter. And I've got my G, sum is done. Right. Now the next bit is to do converse theorems. Converse theorems means that you go backwards. So just like in theorem number 1 we had, if the line from the center is perpendicular on a chord, it would bisect. But if it bisects, it would be perpendicular. But that's also a converse theorem. But these converse theorems are to prove that something is a cyclic quad. Now you know cyclic quad from theorem 5 and 6, right? You go through your whole motion and know that opposite angles are supplementary, exterior angles equal to the opposite interior. Now if I ask you, prove that this is a cyclic quad, your first instinct is to say, ma'am, where's the circle? Are you with me? Because you are going to think that in a moment. But then you're going to forget that, erase that out of your mind, because we're proving now that if I could, I can draw a circle around it, which would make it a cyclic quad. But there's only 3 reasons for that to happen. If I see any quad, anywhere, it could be a cyclic quad, meaning that through those 4 points that I could draw a circle, so they would be concyclic. Now the question is, prove that PQRS is a cyclic quad. It's just a bit, well, being PQTR, if it was, but we're trying to prove that PQRS is a cyclic quad. So before you write down, ma'am, there's no circle, please think again. Okay? So the reasons for that is, one of the 2 that you already know, exterior angle equal to the opposite interior, and opposite interior ones are supplementary. There's another one, namely the bow tie. So I'll try to sum it up here for you. If you can see that the exterior angle is equal to the opposite interior angle, it would mean that those 4 points are called concyclic, which means that that is a cyclic quad, depending on how I ask you. If I ask you to prove that points are concyclic, it's the same question as saying, prove that PQRS is a cyclic quadrilateral. Just different ways of asking it. But to prove that it is, you can do it by saying exterior angles equal to the opposite interior. So that means that those 4 points would be concyclic. This one is when the opposite angles are supplementary. If you can prove that, there should have, would have, could have been a circle around it. And you won't be able to draw that afterwards. Not even the graphic design kids will battle by doing that. Alright. And then this one as well. Man, where's the circle? Are you seeing the bow tie? Yes. So I'm saying in reverse, if bow tie works, what does it mean? That all 4 of those points would be on a circle. There isn't even a quad. And you don't draw in a quad. It's enough to say that those 4 points are concyclic, and if you wanted to say that A, B, C, D is a cyclic quad, although you don't even see the quad. Are you with me? Those are the only 3 reasons why it can be a cyclic quad. So let's have a look at the first example. So you've got to prove that this PQRS is a cyclic quad, and all I've given you is the 108 there and the 36 there. So let's go back to grade 8 and 9. What can you work out? Can you say that there's a diameter and that there's a tan chord theorem? There's no circle, guys. You've got to work with what you have. What are you going to use? Angles opposite equal sides. And 36? Okay, 180. How did you do that? Sum of the angles of a triangle and angles opposite equal sides. So that would mean I've got 144 to divide by 2. That's all I need to write. And over here also I can say that angle R and angle T, let's call it T1, would both be 72. Okay? Don't you first have to say that together they add up to 144 because of the sum of the angles? You can put it in one reason, but then all the reasons must be there. So I've got two reasons here. The interior angles of triangle, RTQ, sorry, would be equal to 180, as well as, what else? Angles opposite equal sides of a triangle. So you're allowed to do that, but if there's three reasons, you're going to write them all. Then it gets too much. Then rather write them step by step. First say, they add up to 144 because of the sum of the angles. Next step, each of them is 72 because angles opposite equal sides. But you're not a parrot, you can have some freedom, but you've got to give me all the reasons. Then what do you see? What do you see? I see that P plus R. I've got to tell them that. You don't have to go show me how you added 108 and 72, but I see that they are 180. 72 plus 108 is 180. Reason? Because I can add. There's no reason. Now I'll say, therefore, P, Q, R, S is a cyclic quad. The question was, prove it's a cyclic quad. So it is because of what? Because of opposite angles being?
Supplementary.
So what do we write? Converse of opposite angles of a cyclic quad. The actual reason is, if I have any quad and the opposite angles add up to 180, then it will be a cyclic quad. But you can just write converse of, converse of, converse of. Finish. How many marks? Like 3. Because you did have to go work a little bit to see that they do add up to 180. And then those points are called concyclic points. Question was, prove it's a cyclic quad, so I'll answer the question. Yes, it's a cyclic quad. One of 3 reasons. What reason would this be? Also prove to me that P, Q, R, S is a cyclic quad. What have I got? Exterior angle. So I'm hoping that R would be 80. But then you can't say R is 80 because the exterior angle of a cyclic quad. You're going to prove it's a cyclic quad. So you can't use it to prove it.
Q1 is 50.
Oh, did I not write it here? This one, 50. Sorry. Thank you. I was just going to say there's not enough information here. If this is 50, then what?
T is
Then
50.
T1 would be 50 because?
Opposite, angles opposite equal sides.
Okay. Angles opposite equal sides and not isosceles triangle. Okay, and then R would be? 80 because that adds up to 100 and I'm short of 80. So R is 100, 80 because of interior angles of a triangle. T, Q, R. And then what do I see?
P2 is 80. 100.
Okay, you can do that if you want to, but I can immediately just say P1 and R are equal to each other. So 100% right to say straight line, 100, 180 adds up to 180 cyclic quad because of the opposite interior ones. I'm just straightly going to exterior angles now equal to the opposite one. Why are they equal? Because they're both 80. No reason here. And then therefore, that could make it a cyclic quad, but please answer their question. They said, prove that P and Q and R and S are concyclic points. And the reason for that is the converse of, what did I use?
The exterior.
Opposite interior angles of a cyclic quad. What did she use? She went straight line, which she's got to write then, and then say opposite angles are supplementary, like the previous one. So you have freedom to work it another way, but that would be the reason I used if I say 80, 80. It's the exterior angle equal to the opposite.
Converse.
Sorry. Converse of the exterior angle of the cyclic quad. Thank you, let's correct that. Okay. The last reason that you could find now remember this can be inside have a big other sketch, and I'm asking you that, and there's other lines and more circles and whatever. If I ask you to prove that PQRS is a cyclic quad, there's one or three reasons. The obvious reason, now because it's nice and small and simplistic, how can I do bow tie here? Would parallel lines be given for no reason at all? No. How would the parallel lines help me? Because I'm thinking bow tie. If I can get maybe these two to both be 30 or whatever they are to be the same, bow tie works, it's a cyclic quad. What do I have?
Alternative.
Okay, so if this is 40, then that'll be 40, right? Because of alternate angles being equal to each other. Then, so I'm thinking maybe I should go for this one being 40. How can I do that? Straight line,
Oh,
sum of the interior angles of a triangle.
and then, oh.
And I see, aha. Not, it's a bow tie, that's why they're equal. You've got to prove it's equal. So what were my steps? I said that S was the same as R1 because of alternate angles and because of SQ and RU being parallel. Don't forget to write that, otherwise you don't get the mark. Then we had that T1 was 110 because of a straight line. And so I got to P being 40 because of the interior angles of triangle, PQT. Then what am I seeing? That angle P is the same as angle S, which was 40. Guys, could I have done the bottom ones as well? Vertically opposite, some of the angles of a triangle, 100%. Okay? So now that I know that they are equal to each other, what's the reason? Not bow tie. Okay? They are equal to each other. So that's why PQRS is a cyclic quad, although I don't even see the cyclic quad. What's the reason? Converse of bow tie. That you mustn't write angles in the same circle segment. So there would have been a circle drawn through P and Q and R and S. I wouldn't be able to do it, but that would have been the problem, the solution. So guys, please, you're going to do it for me. The next, well, there's 4 sums left. I want to mark 2 of them tomorrow and 2 of them the next day, and we still have to do the analytical as well. So please do the next few ones, proving that it's a cyclic quad.